This is our measurement simulation for SL Physics, so let's get started. First things first, you're measuring two different things in the simulation. You are measuring your independent variable, that is the radius of the circle, and corresponding trial measurements for your dependent variable, the circumference of the circle. First thing you will do for your IA or any experiment in the class is you will get the uncertainty of the measuring device. To do that, you'll look at the scale or whatever you're using to measure. For this, it's a ruler, and I can see immediately that the smallest increment of measurement or the precision of the device as is a tenth of a centimeter or a millimeter. However, we could divide the scale further, and if I do that and I zoom in, I can actually see this will go further than a millimeter. This will go down to a tenth of a millimeter or a hundredth of a centimeter. So using this, you could further divide the scale also and continue to zoom in, but I'm just going to leave it as a tenth of a millimeter. So we will record the uncertainty of the measuring device. For this example, this uncertainty is plus or minus 0.001. I'm sorry. This is plus or minus 0.1 centimeters. A hundredth of a centimeter is the uncertainty of the measuring device. Okay. I can zoom back out and I can measure the radius by grabbing this green circle. Grabbing the green X and moving it down to the middle of the 0 centimeter line, and then I can estimate here along the length that the radius of the circle is half of a centimeter. So I'll record that measurement. What is the measurement for the independent variable for this variation? It is 0. It is 0.50. I will include the 2 decimal places of precision, plus or minus 0.01 centimeters. And notice if I have 2 decimal places in the measurement, I will have 2 decimal places for the uncertainty of the measurement. And what is the measurement for the corresponding dependent variable? So I'm going to look at the circumference. I'll zoom back out, and I'm going to get the circumference by grabbing the red X, and I can just roll this circle down along the measuring device. Pretty nifty. And then I can zoom back in, and I can see that this is 3.1. Every big tick mark is a millimeter. So 3.1, and then I'll count. 1, 2, 3, 4. Okay. So this would be 3.14 plus or minus 0.01 centimeters. That's my trial 1. How many trials for the dependent variable? Well, IB says 3 trials for your for each variation of the independent variable. So we need a total of 3 trials. So what I can do is I can come back here and I can look, and I am limited to the precision of the device in this case. Estimating beyond the uncertainty I've provided, I should not do for this. So if I look, I could say it goes slightly beyond 3.14, so I would round up to a whole uncertainty value. I could say, okay, trial 2, my measurement is 3.14 plus or minus 0. I'm going to round up in this case. I'll round up to a whole number, 3.15 plus or minus 0.01 centimeters. And again, the reason I'm doing that is because I'm estimating I'm telling myself I don't feel confident estimating beyond 0.01 centimeters. So I'm just gonna, I can see that the X lies slightly above this tick mark, but I can't estimate really where. So I'm gonna round up to the next highest interval, which would be 3.15. I can see though it still lies really close to the fourth tick mark, so my third trial could just be 3.14, again, plus or minus 0.01 centimeters. So I have trial 1, trial 2, trial 3 corresponding to this independent variable. You're going to do that 5 more times. And again, get 3 trials of your independent variable. So IB says 6 variations of the independent variable, and 3 trials of the dependent variable. So hopefully you got something out of this video. Thanks for watching.